7 miles underwater, the pressure is so extreme it could crush a submarine like a soda can. But what would it actually do to your lungs, your brain, your blood, and every single organ in your body? The answer is more terrifying and more fascinating than anything you've ever imagined. Picture this. You're standing at the edge of the ocean, looking down. Somewhere beneath your feet, there's a place so deep it could swallow Mount Everest whole and still have over a mile of water above it. Then that place is the Mariana Trench, located in the western Pacific Ocean near Guam. It stretches 1,580 miles long and plunges down nearly 36,000 feet at its deepest point, a spot called Challenger Deep. Most people don't realize we know more about the surface of Mars than we know about this trench. Only a handful of humans have ever been down there, and none of them went unprotected. Because the moment a human body meets that pressure without armor, it starts losing a war it never had a chance to win. Here's the number you need to understand. 15,750 pounds per square inch. That is the pressure at the bottom of the Mariana Trench. At sea level, air pushes on our bodies at about 14.7 pounds per square inch. We never feel it because our bodies are built for it. But go down to Challenger Deep, and that number explodes to over 1,070 times what you feel right now. Every single square inch of your skin would be holding the weight of a small car. Your chest, your face, the back of your hands, all of it, crushed by 8 tons per square inch. That's not just pressure. That's a force so overwhelming that even titanium submarine hulls have to be engineered to absurd tolerances just to survive it. Your body, made of flesh and bone, would not even come close. Before you get anywhere near the bottom, your ears start screaming. Every 33 feet you descend, again the pressure increases by 1 full atmosphere. By just 100 feet down, your eardrums are already under serious stress. The eardrum is a thin membrane roughly the size of your thumbnail, and it is not built for rapid pressure changes. Without equalizing, that membrane ruptures. Divers call it a squeeze. Your sinuses go through the same brutal process. Every air-filled cavity in your skull acts like a balloon being slowly crushed. At recreational diving depths, this is manageable. Just heading toward 36,000 feet, it is catastrophic. Your lungs are next. The human lung, fully inflated, holds about 6 liters of air. The deeper you go, the more that air compresses. By 100 feet, your lung volume is already cut in half by Boyle's law. Double the pressure, half the volume. By 300 feet, your lungs are squeezed to roughly the size of a fist. At 1,000 feet, they are essentially collapsed. At 36,000 feet, the air inside would be compressed so violently that the lung tissue itself would implode. The walls of your alveoli, the tiny air sacs responsible for oxygen exchange, would shred and rupture. Blood would flood the lung cavity. You would not be breathing anymore. You would be drowning from the inside. As pressure builds during descent, the gas dissolved in your blood, primarily nitrogen, starts behaving in dangerous ways. At depths beyond 100 feet, nitrogen narcotizes your nervous system. And divers call it the rapture of the deep. It feels like being drunk, confused, and euphoric all at once. But the real threat is the massive amounts of nitrogen being forced directly into your bloodstream. If you were to ascend too quickly, that nitrogen would bubble out of your blood, like carbonation in a shaken soda can. Those bubbles tear through tissue, block arteries, and cause strokes, paralysis, and death. That condition is called decompression sickness. The bends. At Mariana Trench depths, the nitrogen saturation in your blood would be so extreme that no controlled descent could ever save you. Here is something most people never consider. Under extreme depth, your body triggers a survival reflex called blood shift. Blood is forced away from your extremities and toward your core. This is actually what allows elite freedivers to reach depths of 700 feet without dying instantly. Their lungs partially fill with plasma, preventing full collapse. It is one of the most remarkable adaptive mechanisms in human biology. but that adaptation only works within a narrow range. At Mariana Trench pressures, the force overwhelming your entire cardiovascular system would be so immense that your heart walls themselves would compress. The chambers that pump blood would struggle to expand between beats. Your heart would not stop dramatically. It would simply lose the physical ability to beat against the crushing force surrounding it. Thus, the human brain floats inside your skull, cushioned by cerebrospinal fluid that acts as both shock absorber and pressure regulator. Under normal conditions, this system is nearly perfect. But as outside pressure escalates beyond anything the skull was built to handle, cerebrospinal fluid cannot compensate fast enough. Blood vessels in the brain bulge and rupture. High-pressure nervous syndrome, documented in deep sea divers, causes tremors, hallucinations, cognitive collapse, weed and seizures at depths far shallower than the Mariana Trench. At 1,500 feet in a pressurized environment, trained divers have reported losing the ability to think clearly or control their own bodies. At 36,000 feet of open water pressure, your brain would simply cease to function as a coherent organ. Most people assume bones would be the first thing to snap. Surprisingly, that is not quite right. Bone is dense, solid, and relatively incompressible. It does not have air pockets, so pure hydrostatic pressure does not crush it the way it crushes hollow structures. But your joints are a different story. Every joint contains synovial fluid and small pockets of dissolved gas. Under extreme pressure, those gas pockets collapse violently, causing joint surfaces to grind together without cushioning. Your cartilage would crack and splinter. And then there is your digestive system. Your stomach, intestines, and colon all contain gas at any given moment. At Mariana Trench depths, every one of those gas pockets would implode instantaneously. Your stomach walls would collapse inward. Your intestines would compress and rupture along their length. The entire digestive tract would fold like a crushed plastic bottle. Your eyes are soft, fluid-filled organs. As external pressure skyrockets, this internal eye pressure cannot keep pace. Blood vessels across the sclera rupture almost immediately. Vision distorts, then blacks out entirely. At pressures approaching Mariana Trench levels, the eye itself collapses inward. The skull, despite being one of the strongest structures in the human body, faces its own reckoning through its natural openings. The eye sockets, nasal passages, and the base where the spinal cord enters all act as weak points. The water forces its way through every one of them simultaneously, like a fortress breached through every gate at once. Now, imagine you are teleported straight to Challenger Deep with no protection. Here is how fast your body betrays you, second by second. At time 0, your eardrums rupture instantly from 1,100 atmospheres slamming your skull, followed milliseconds later by your sinuses exploding inward. Within 1 second, your lungs compress to 1% of their normal volume, soon alveoli shredding as blood floods your chest cavity. By 3 seconds, nitrogen narcosis hits your brain so hard, you lose consciousness before you even register pain. Heart chambers cannot expand against the pressure, and cardiac arrest follows at 5 seconds. Eyes collapse by 10 seconds. Stomach and intestines implode around 15 seconds. Your entire body reaches hydrostatic equilibrium, every air pocket gone, roughly 30 seconds after arrival. You are not crushed into a small ball like in the movies. You become a liquefied, pressurized sack of ruptured tissue. Total organ failure in under 1 minute. Only a tiny number of humans have ever reached Challenger Deep, every one of them sealed inside engineered shells. Don Walsh and Jacques Piccard descended in 1960 aboard the bathyscaphe Trieste, spending just 20 minutes at the bottom before their viewport cracked under pressure. James Cameron made the trip solo in 2012 in the Deep Sea Challenger, spending about 3 hours collecting samples. Victor Vescovo broke the record in 2019, reaching 35,853 feet in his submersible, the DSV limiting factor. What Vescovo found stunned the scientific community. Not just geological formations and bizarre creatures, but a plastic bag and candy wrappers at the deepest point on Earth. The ocean floor of the Mariana Trench had already been reached by human pollution before most submarines could get there. Here is the twist that changes everything. While your organs would be obliterated within seconds at Challenger Deep, there are organisms down there that have lived under that pressure for millions of years and are doing just fine. Tiny crustaceans called amphipods have been found in massive numbers at the very bottom, and these creatures survive because their bodies contain no air pockets whatsoever. Every cell, every tissue, every fluid inside them is already at pressure, equilibrium with the surrounding water. Their cell membranes are packed with special unsaturated fatty acids that keep them flexible and functional under pressures that would turn human tissue into paste. Scientists have even found single-celled organisms thriving in the mud at Challenger Deep without sunlight, without warmth, under pressure found nowhere else on Earth. The lesson is stunning. Life does not fear pressure. Life adapts to it. The problem is not the pressure itself. The problem is that your body was built for a world it never had to leave. The subs that reach Challenger Deep live on the edge of human engineering. Cameron's deep-sea Challenger used a titanium pressure hull just 6 inches thick, shaped like a soda can to distribute force evenly, weighs enduring 8 tons per square inch, while external cameras failed from the pressure. Vescovo's limiting factor, made of 5-inch thick titanium, completed multiple dives proving reusable. Deep-sea technology is possible. These subs use syntactic foam for buoyancy, a material with microscopic glass bubbles that compress just enough without imploding. Yet even they face near disasters. During one dive, Vescovo's viewport pinged under strain, a sound engineers called the voice of the abyss. Every bolt, seal, and weld fights for survival. The Mariana Trench proves nature still holds cards we cannot play. 7 miles down, life thrives without sunlight or mercy. Your body crumbles in seconds. But every dive teaches us something. Amphipods laugh at 15,000 pounds per square inch. Subs push engineering to its absolute limit. Freedivers unlock ancient biological reflexes. Humanity stares into the abyss and says, "Challenge accepted." Next time you stand at the beach, remember this. And beneath your feet lies a world more brutal than space, more unknown than Mars, and more humbling than any mountain. The ocean floor holds secrets that could rewrite medicine, materials science, even evolution itself. We have only scratched the surface of what lies beneath. Stay curious. Stay alive. If this deep dive blew your mind, smash that like button right now. Share this with someone who thinks they could survive the trench. Subscribe and hit the bell for more science that hits harder than 15,000 pounds per square inch. Drop a comment below. Which organ surprised you most?